Hello, and welcome to Palisade Corporation's webcast, Schedule Risk Analysis for a Large Development Program, presented by James Aksel. My name is Jameson Romeo Hall, and I'll be your host today, and I will be available to help answer technical questions by chat. At this time, all attendees are in a listen-only mode. Please note that as an attendee, you are part of a larger audience today. The attendee list is suppressed to maintain attendee privacy. We will be holding a Q&A session at the conclusion of today's presentation. You may ask an online question anytime throughout the presentation today by clicking on the Q&A panel. I would also encourage you to visit our website and sign up for a free trial download of our software, including our lead products at risk and the Decision Tools suite. We invite you to sit back and relax and enjoy today's presentation. I would now like to introduce your presenter, Jim. You have control of the webcast.
Well, good morning, everyone. Hopefully everyone can hear me. If there's problems with the audio, please let the host know so that he can contact me offline. My name is Jim Aksel. I'm 35 years experience in the aerospace and defense industry. Part of my background includes co-authoring of the second edition of the Project Management Institute Practice Standard for Scheduling, which does include provisions for risk analysis, as well as the latest DID for Program Performance Management Reporting, the 81861, as well as participation in the development of the U.S. Government Project and Scheduling Excellence Guide. My company does full EVMS capabilities. If it's cost and schedule related, we can do it regardless of your background. So I guess those are my qualifications for doing schedule risk assessments. I've done about 8 or 9 of these. And there's my contact information, which will appear later. So what exactly is a schedule risk analysis? Oh, I hate it when that happens. We'll go to basic mode. Okay. So what's a schedule risk analysis? A Monte Carlo simulation of a compliant schedule model, and I'm going to define what compliant means in a minute. Work and breathe properly, then the results are typically useless. So what a schedule risk analysis does is helps us establish a time frame for event completion. That might be somewhere along the mid-course of the program itself, or it might be the program end date. So we can plan to a system requirements review, or to start of manufacturing, or to delivery of some software product. If the schedule model happens to be cost and resource loaded, we can also use these capabilities within the at-risk tool and the decision suite tool to help model cost parameters as well. So let's see if we can take a look at this pictorially. What are we really trying to do with a schedule risk assessment, or what are we really trying to do with any program in general? If we take a look at the bottom axis, that's time, duration in terms of percent complete of the entire project. So generically it's normalized duration. And then generically on the vertical axis we have normalized money, or the amount of money it's going to take us to get the job done. So we took those out to 0 to 100%. If you take a look at this point right here, I don't know if you can see my mouse, but right at the end of this dark black line, that's where we plan to be. That's the static point at which the program starts. But in reality, we all know that things don't go exactly according to plan, and there's various different ways that we can predict how much money we're going to spend and how much time we're going to take. Monte Carlo simulation is part of defining what's going on the horizontal line, the bottom of the red box, and money is defined by the vertical red box, vertical line. So in reality, what are we really trying to do? Any program will tell you we're trying to stay in the box, right? We want to land in the box. And what we're trying to do is help you define at least the horizontal dimension of when we think the program will complete within a given percentile or a given confidence interval, typically 95%. In today's example, I can't get into a whole lot of detail because it's the United States Navy missile program. It's a prime contractor with one subcontractor. I was consulting for the prime contractor. So it's a master and sub-project file situation where there was over 5,000 discrete non-level of effort tasks What that means is the schedule was fairly complex and was spread across multiple files. Additionally, there was some correlation required, and actually I will show you later on in the presentation how that could have been avoided. I was just too rambunctious in trying to use correlation and, as part of the demo, so we figured out we'd just do that. Also, there was some probabilistic branching due to some obsolescence issues with some of the components that were going into this missile. So that kind of covers the big bang things that at-risk will do for us. So I figured I'd roll those into the model. As for preliminaries, there's a couple of things we need to do. We need to prepare the schedule model properly within Microsoft Project. And then we also have to take a look at Microsoft Excel and the computer itself, because some of these simulations do run for quite a bit of time, and we want to make sure that there are no interruptions or that things are going to proceed as quickly as they can using the maximum of the hardware and software that are available. So if we take a look at the schedule model itself, we need to consider that there has to be proper status in the schedule. And by that I mean the easiest possible way to explain it is nothing really did happen tomorrow, and anything that's left undone yesterday is still undone. So my 4 rules are: 1 was the finish date yesterday, quote, meaning less than the status date. If the answer to that is yes, that task must be 100% finished, or you must reforecast the duration so that the finish date is the status date. Same thing with start dates. Is the start date to the left of the status date, then that progress must be greater than 0%. If it's not, you need to reschedule the task. Also, similarly, stuff didn't finish tomorrow, right? Today is, for all intents and purposes, September 1st, 2014. You didn't start on October 12th of 2014. You just didn't do it. You had to start at a date earlier than today, so make sure you did that. Same thing if a task is 100% complete, its actual finish date has to be less than or equal than the status date. Further, everyone has to have a proper successor. I have a white paper on this. I'd be happy to provide it on request. Things that are complete when you're done with a task, somebody has to care that you're done. If nobody cares that you're done, then you need not be doing that particular task. So you need to have a finish to start successor or a finish to finish, some type of successor that drives the start date of something else. Otherwise, you're doing work for no particular reason. Also, if you take a look at the screenshot of Microsoft Project Options, the most important thing is the arrow right there. It says task will always honor their constraint dates. No, you don't want that. You want the tasks to float and to have negative float if necessary to meet the requirements so that the tasks are actually moving left and right as we do the Monte Carlo. Further things that work to help keep the model running cleanly: 1, clear all formulas and lookup values. The at-risk software doesn't need them. Delete any data that's not necessary, particularly in custom fields. If the program is going to be reserving data in fields, then you need to not be having corruptible data in the field. And also just retain, min, most likely, and max. I use duration 1, 2, and 3 for those values, and then those can be imported into the tool. Level of effort, you can set those as hammock tasks if you want, or you can put them as hard duration tasks. What we do is we take them out. Those things shouldn't be driving your critical path, and they ought not to be in your schedule for a risk analysis. Now, that might mean that you have to re-wicker your logic, right? But typically you shouldn't be having logic on level of effort tasks anyway, so that shouldn't be a big deal. Remove all constraints that are must finish on, must start on. You shouldn't have those in your schedule anyway for it to be healthy. You can retain SNETs, start no earlier than, but only if they mean something. For example, I'm doing a schedule risk analysis for a client right now, and they know that they won't have resources available for about 6 weeks on a particular task because there's a special consultant that they're bringing in to do some of the work. Well, that's reason to have a start no earlier than, because it's an external constraint. But don't let SNETs drive internal logic within this schedule. Same thing with start no later than, finish no earlier than, and finish no later than. So retain only what's absolutely necessary from external events. Now let's take a look at Microsoft Excel. Please make sure you have the latest service packs installed. We're in Microsoft Excel 2013 right now, and the product supports that quite well. Your fastest simulations are going to, believe it or not, be with Excel and Project 2007. I'll talk about that in a minute. But we are completely compatible all the way up through 2013. You need to enable, or you should consider enabling multi-threaded calculations. It's under File and then Options, and then pull the Advanced tab, and then on the red box there on the right, use all the processors that are available to you. The 64-bit version of Excel will crunch a bit faster. There is some trouble with that, however, because if you have one 64-bit application on your machine for Office, you have to have all 64-bit apps. So it kind of gets to be a circular reference. Either everybody's 32-bit or everybody's 64-bit. So if you do it for one, you have to do it for all. Let Windows manage your virtual memory. You can do that through Control Panel, and get help from your IT people if you need to. Also, go into your BIOS and into your power management on your screen. Make sure you've got your screensavers turned off. No automatic shutdown, because you run this thing, you're going to turn around and leave, and the last thing you want to do is put your computer to sleep after 15 minutes, right? So sometimes it takes some time to do this. What I've done in the past is I have two machines. I have a work machine, and then I have another machine that I can use for doing just this type of work, which is a very robust machine. And I just use that machine so that I can continue to work while numbers continue to crunch. Now let's take a look at the triple point estimates. Oh, if I could back up for just a second, I found that disk access time and file swapping is what slowed my performance down the most. I have the ability to, if you go into the performance monitor, you can see how badly your CPU is being crushed, as well as your RAM, and I had plenty of that available. It was the file swapping, and there's nothing much you can do about that other than some of the Windows settings. So that's some advice on that. If you have a solid-state hard drive, it's going to run a bit faster. Let's talk about triple point estimates. We need to use remaining duration for minimum, most likely, and maximum. Triple point estimates are usually developed by the control account manager, and they need to be supportable. There should be some type of evidence to back them up based on historical data or other rationale as to why you think things are what they need to be. I have a slide on that in a minute. Consider also there are tasks with no upside or no downside. For example, a task with no upside, it has a minimum close to the most likely. In other words, when we do the Monte Carlo simulation, I've got a minimum of 4 days, most likely of 5 days, and a maximum of, say, 22 days. Well, that task has no upside, really. I mean, most of the time, the Monte Carlo is going to throw the dice, and you're going to be picking a number larger than 5. So that's a task with no upside. Be careful of those. You need to support why the min is so close to the most likely compared to the max. Also, tasks with no downside. I've got a task with a maximum of 10 days, a most likely of 9 days, and a minimum of 2 days. Well, there's a lot of opportunity there, but ask yourself, why am I estimating 9 days with a maximum of 10, and what really makes it so that it won't be more than 10? Also, there are programs that have inherent high risk. If the max minus the min, in other words, the variance in duration, so I have a task that's 4, 5, or 6 days in duration, 6 minus 4 is 2. Take that 2 and divide it by 5, which is 40%. That would be considered inherently a high-risk task because it exceeds more than 25% of the most likely estimate. That's just a risk monitoring factor. It doesn't mean you shouldn't use it, but the industry tends to like it when max minus min is not more than 25% of most likely. It means that you've got your scheduling a lot of faith in it if the variance is less than 25% and that you've put a lot of thought into it. So the more rigor that you put into these estimates and supporting the minimum, most likely, and maximum dates, the easier you're able to defend it, and actually the better your results are going to be. So again, is there data available to support a more realistic distribution than the one you're using, right? Most distributions require only a mean and a standard deviation or some other leverage factor to make the spread. So think about that if you have historical data that you can use to try to do some type of curve fitting. I'm actually reminded of a story of there were 3 guys that interviewed for a job. One was a mathematician, and one was an actuary, and the other one was an accountant. And the mathematician went in and he interviewed first. And they said, well, very good, but we have one more question for you. What's 2 plus 2? And the mathematician said, well, it's exactly and precisely 4. There can be no other answer. I said, okay, so we'll get back to you. And then the accountant interviewed next. And, of course, the interview went equally well. And they said, well, we have one more question for you. Well, what's 2 plus 2? And the accountant said, well, did you need that before or after taxes? And they said, oh, yeah, we hadn't thought of that. Good idea. We'll get back to you. Thanks a bunch. And the actuary goes in last. And, of course, actuaries are the guys that play statistics about people's life expectancies and probabilities of events occurring in the future. And, of course, his interview went very, very well as well. And they said, oh, we do have one more question for you. What's 2 plus 2? And he looked really stunned, and he got really quiet, and he ran over and he closed the curtains, and he ran over and he closed the door, and then in a very quiet voice he goes, well, what'd you guys need it to be? Now, it does relate here because the triple point estimates have to be reasonable, right? You can't fix it to be an answer that you want it to be. Part of my philosophy when I do these risk assessments for clients are the model is only going to produce a result depending on your inputs. And if we all agree on what the inputs are, and I make everybody put their hand up and say, yes, I agree with these inputs, well, then the model produces a result. You don't get to not like the result. You liked the inputs. I'm sorry that you don't like the result. We need to process the result, not question it. Now, there are some times where obviously there's a very wrong input that we don't discover until later. Okay, I get it. There is a statistics book out called Statistics by Mario F. Triola. Triola is the author. And he said that we need to be using statistics and this type of information as a lamppost. Not how a drunkard uses a lamppost, but support, but for the intended purpose of the lamppost, which is for illumination. So I kind of like that. I've always remembered it, and it makes for good sense. We use this type of model for illumination, not for support. Let's take a look at some other ways to look at estimates. We need to have triple points, and we need to have very defendable triple point estimates along the critical path of the network, with the relative critical paths, the first, primary, secondary, and tertiary. However, there are other tasks that are involved. We had 5,200 tasks in this one that we're talking about right now, and only about 100 of those were actually on a critical path. But what do we do about everybody else? Some of my contemporaries say, if they're not on the first 3 primary paths, don't worry about it. Well, I tend to be a little bit more rigorous than that, and I want to put a band on everything so everyone can say, well, then everything else is plus or minus 10% or minus 5 plus 10%, whatever can be supported. I look at, for this banding, and you can do this along the critical path as well, but I look at two factors. One is the process risk. If I have a process which is really just a checklist, did you do this? Check. Did you do that? Check. Almost like a police officer writing a ticket. He's got certain steps that he has to take, right? And those can be written out in directions and just checked off as you go along. That's actually a very low risk process, as opposed to, fermenting wine or something, which there's a lot of finesse and artistry that's involved in the process itself, as opposed to the end product. Now, the end product might be a specification, it might be a piece of hardware, it might be a piece of software, but there's product risk, which is also scored on a scale of 1 to 5. So I can score process risk on a scale of 1 to 5, and then I can score the product risk on the same thing about what is actually produced from the process, and I can score that from 1 to 5. Things that might be considered: is there a high probability or need for rework? Is there a possibility of rejection? What about tolerance stack up? What about a junior guy doing the task and it's going to take more time to process through the peer review, but not necessarily generate the document? Those types of things could be product risk. The example I just gave, I could probably equally argue that that's process risk depending on who the person was. So then anyway, you can score those both 1 to 5, and typically what we do is we multiply those together. And I didn't bother to fill in durations here because I don't want people to say, well, Aksel said use these. Well, you got to use the duration percentages that mean something to you. So if you think about it, if I have a product risk of 1 to 5 and a process risk of 1 to 5, my score can range anywhere from 1 to 25. There are certain exceptions. I can't multiply two numbers together and get 11 or 13, for example. But these are qualitative assessments of product risk relative to one another, 1 to 5. And you're going to get a score of 1 to 25. And then you can establish your own bands, and you can say, well, 1 to 5 is really very little risk. You can make that 1 to 7 if you'd like. You can make it 1 to 3 if you'd like. The same thing with the rest of the bands. And then you could say, well, for this low-risk stuff, it's going to be -2% plus 3% or whatever. And so the values of X can change as you go down the table. The values of Y can change as you go down the table. They don't have to sum to 100. None of those rules apply. It's just the more risk, maybe there ought to be more span for the minimum duration and the maximum duration, but that's up to you. And you need to supply your own values and score bands, whatever you can support. That's really what matters. And then you can apply that as global banding to quote the rest of the tasks, and the at-risk tool allows you to do that quite nicely. Something else to think about. Let's take a 5-day task, and the risk band is -5% to +10%. That means that 5% of 5 days is 2¼ days. I'm sorry, it's a quarter of a day, and 10% of 5 days is a half a day. Well, really, a 5.5-day task, you've got 40 hours, and you're really going to think you can estimate that to somewhere between 38 hours and 44 hours? Probably not. So our estimates on tasks are generally, it's 10 days, it's 5 days. Well, apply that same type of rigor and make sure that everybody varies by at least a day. So I always set things up so that, even if we might be using -5% and +10%, I go back through and I make sure that I use 4, 5, and 6 for those types of tasks, or 8, 10, and 12, whatever it is, and make sure that everybody rounds off to an integer number of days. It's just something I do. It's certainly more supportable and reasonable, isn't it, to say 4, 5, and 6 rather than 4.75? Are you really that good at estimating? No, none of us are. So take a look at that. It does drive the risk inherent, because if you take a look at that, 6 minus 4, I had mentioned before, is 40% of 5. So that task would be, quote, inherently high risk. Well, come on, it's 5 days. I can probably estimate a 5-day task a lot more accuracy than I can a 20-day task. So, just keep that in mind. The banding of -5 to +10% really, in this case, if you do the math, it really only applies when the duration is more than 20 days or 20 days or more. So just think about that. More on triple points. They need not be symmetrical. Everyone seems to think that they need to be, but no, they don't. Banding using plus or minus X days or X% is simple. It's not very rigorous, but even when you're doing it with critical path tasks, you can establish triple point estimates that are 4, 5, and 18. There's no reason why you can't use that if that's really what it takes. If I apply more rigor onto a primary, tertiary, and secondary critical path, some of the things I may want to consider are historical performance of similar tasks. Decomposing the task into smaller chunks. A 20-day task can more than likely be broken down into a couple of 4-day tasks, or two 10-day tasks, that type of thing. And the narrower the margin, the smaller the task you're estimating, the more accurately you're able to predict what the minimum and most likely and maximum would be, and then you could just sum that back up. You can also use by analogy, or this is 20% more complex or less complex than something else. Number of units is assigned. Go ask a bunch of experts what they think it would be. Go to the graybeards, or just the pure amount of effort that's involved in the task, such as a 100-hour task might have more inherent risk in it than a 40-hour task, even though they're both the same duration. So take a look at those things and consider them. Use a triangular distribution. That's what we do. It has the largest standard deviation of all the common distributions. And what does that really mean? Well, if you think about it, and I've got a formula that we're going to show here in a little bit, what really drives the variance in your program or in your task durations is the standard deviation of the task. And it's a function of points A, B, and C, the minimum, most likely, and maximum durations. And there's a big long formula you can go through and divide by 18 and take the square root of that, and you have the standard deviation. The biggest value that you'll come up with is for a triangular distribution, rather than using the same distribution, different distributions with the same triple points. And we do that because it drives uncertainty. If I can put uncertainty into the task and into my estimates, and I can say, well, Your Honor, when I did this, I used a standard deviation that was large because it would produce more variance, and therefore that would produce more uncertainty in the results, so that my bandwidths would be wider and that my endpoint would be further to the right, and I would be purposely skewing my model to be what I call more conservative. Besides, triangular distributions, very easily understood, and only requires 3 points. So let's take a look at that. Is that triple point really normally distributed? No, it's not. There's the normal distributions that are laid on top of it, and you can see that by far the maximum is out to the right. So use the proper distribution. That's not a normal distribution on that particular one. By definition, a normal distribution is centered and symmetric, and this triple point is not symmetric, so I wouldn't even dream of using a normal distribution there. Some other hints. You can check in the project settings on at-risk when you're in Excel and you have the at-risk toolbar displayed. Go into the project settings and take a look at the check engine and see how the simulation is set to automatic. It's going to check between a standard engine and an accelerated engine, and if it can use an accelerated engine, it will do so. It will actually run a little bit faster, but you know what I do? I pick one. I see if it'll meet the requirements for accelerated, and in this particular example, it did not because it was a master with sub-projects, so I just set it to standard. Why did I do that? Because the software takes quite a while to actually go ascertain which engine it wants to use and then acts accordingly. I just take that decision away and then say, you know what, don't bother to check. Use the standard engine and you save the time that it takes to make that check. Also, have a Microsoft project table ready that displays the values that you want, particularly the values for remaining duration, also summary tasks and level of effort tasks so that you can filter them or not work them. What I do is I make a couple of changes, like say for example I'll apply a table and I'll put the duration 1, 2, and 3 in it, and I'll put whether or not there's a summary task, and then I'll save and copy the file. And then I'll start taking out that level of effort and I'll save a copy of the file. The reason being, when you do this, if you have several versions of the file, when you realize that you've made a mistake or you need to make a correction, you can go back and get some of the earlier version of the file so you don't have to keep reworking your input file. Now remember, you're always doing an at-risk simulation, a Monte Carlo simulation and a schedule from a copy of your real schedule, not the real schedule itself, right? So you're going to take a copy, and that way you can feel free to take all the extra data out, all the formulas, no drop downs, no pick list items, anything like that. Just make sure it's all gone, and then that way it'll tend to run a bit more quickly. Also, I discovered something else here. If you want to copy down things like remaining duration, or if you want to copy down other things or filter, you can unprotect the sheet. This is the sheet that that Excel displays for the at-risk data. You've got your Gantt chart on the right-hand side, and you've got these columns on the left-hand side. If you unprotect the sheet, then you can turn on your filtering. You'll be able to copy things down for, like, for example, your duration 1, 2, and 3 for your minimum, most likely, and maximum, especially if you're going to be using banding. You can put formulas in there and have it calculate, and then copy and paste over as values so that you have them. And then that works very well. The thing to remember, though, is put your protection back on before you continue. Otherwise, you can run into some pretty strange results. Let's talk about correlations. And in the DoD world, where I do 90% of my work, you cannot mix labor hours with material dollars. So I can't put 100 hours of human labor on one task and then also put, $500 worth of 2x4s. You can't do that in my world. You have to have a separate task that has the material on it, and those two tasks, of course, would have to run in parallel. So that's an ample reason to use correlations. The other thing is, for example, if I have a long preparation time for a test, the test might run for a long time as well. So you can say, well, if you're going to pick a long duration for preparation, then you also need to pick a long duration for test time. So they give you a matrix here, and that the matrix here says that I have a perfect one-to-one correspondence between tasks B and C. And I did that for the tasks where I had purchased labor. We had hourly people that were brought in as consultants, and they were working on software development. They came in as dollars. And then we also had other people that were W-2 employees, and they came in as hours. So we had to correlate that as one-to-one because they had to be working in parallel all the time. But if we were really smart, think about this. The task is going to take how long the task takes, and it doesn't really matter whether they're material dollars being spent or hours being spent. The risk analysis is really here to determine duration, not per se dollars, although if we have dollars in the tasks, we can do that. So really a smarter thing to do would have been to just eliminate all those parallel tasks, just take them right out of the schedule. However, we did not want to take the time to go through and inspect to make sure everybody had the same predecessors and successors on those two tasks that were running in parallel. If they did, then that would be no problem to just delete one of them. But we didn't want to take the time to go through that, so we just established a 100% correlation between them, and then they drove whatever they drove, and that worked out fine. But that would have been a time-saving device as well if we would have taken a look at that logic a little bit more closely. We had a problem with about a 90% chance of obsolescence within the program. There was a particular black box that was flying on this missile that was probably going to be going out of production, so we had to see if we could find something else or use something different to work around the problem. So that's a perfect case for probabilistic branching. We're either going to find out that I have an obsolescence problem or I don't. So you have to, in order to do probabilistic branching within the schedule model, there has to be a choice that exists at the completion of the task. And there has to be at least two different opportunities. And that each of those paths that you're going to go down has to be mutually exclusive. I'm either going to use black box A or I'm going to use brand X. I can't use them both. I'm going to pick one path and then choose to go down there. The sum of those probabilities have to be 1. I said in my case I had 2 choices. It was 90% for obsolescence and 10% for not. Actually, it was 90% that we wouldn't have it and 10% that we would. So we put that into the model, and I have some slides on that. And then you can drive those tasks to anywhere in the schedule model. They don't have to be right next to each other, nor do they have to even end in the same place, other than at the end of the program, right? But they should trace forward to some common consequence down the road, like testing or first flight or something. But they don't have to necessarily be the next available successor. So what I did was I used the inactive tasks, and this was in Project 2010 that we did this particular simulation, although Project 2013 also works. Also, what about risk register items? You know, they may or may not be active in your schedule, and you can put those in as well. So let's think about that. Here's an example of what we're doing. Check my time here. Oh my goodness, we have to get going. The prerequisite branches are 90% for choice A, and choice 2A is 10%. Notice I have the prerequisite with 2 successors, and it drives 2 completely different paths. The inactive tasks of choice 2 are in no way related to choice 1, and then everybody all lands up on that we all land here task. So that's what we put in there for the logic, and then we turn that on and we let it run. The reason why choice 2 was not there was because it would drive out the static dates of the schedule, so we had that turned off. So here's how we established the probabilistic branching, just the names of the branches. And then we got to the main event and ran for several hours. And here's what we came up with. This is the pièce de résistance. We had a 95% probability of finishing no later than 5/21 of 21. I'm not allowed to say how that actually compared to the static program finish date, but what you can say is that usually because of merge bias, multiple critical paths or multiple paths through the network, your probability of attaining the 5% date, which in this case is 2/8 of 2021, is actually probably pretty small. The goal is you're properly planned, or you have a good bunch of schedule margin. If you have margin on tasks and you're able to push the, in this case, the program end date, so that the probability of occurrence is somewhere within this 90% window. And you can do that with schedule margining, and if you contact me offline, I can show you how to do that or explain to you a little bit more. That's probably an enhancement for a future presentation. So here's the effect of the critical of the conditional branching, right? The big stuff on the left is the 90%, which is where we landed, and there's that big gap in there just because that 2014 date, July 4th through the 8th, is a long weekend. That's why there's a gap there. And then you see on the right-hand side, circled in blue, that's the capture of the conditional branch where it actually went and did it 10% of the time. You'll notice that the height of those is about 10% of the height of the other ones. And if you look just within the circle, you can see how it's reasonably normally distributed, as is the large bump. Let's talk about a tornado chart. Tornado chart gives us the sensitivity of specific tasks as they're related to the duration of the, or the impact on, in this case, the program end date, but of at least of the task in question. And it shows that conduct system requirements verification was our main driver, and it could pull that to the left by quite a bit or push it out to the right. I forget the date that it's actually centered on. Oh, the baseline date was the end of March. So it looks like it pushed it symmetrically about a month. These need not be symmetric. Take a look at the air vehicle procure DTB 1 and 2. There's some risk there, but a little bit of opportunity. That stuff to the left is opportunity. So if you can hold these guys to the minimum of that duration, that's where you want to spend your money, and you'll get your most bang for the buck on that top task. You can also get the correlations here. Again, that shows the top task. The correlation shows that we got a 66% chance of getting more bang for our buck if we choose to spend money there to help reduce that duration. So how do you know when you've done enough simulations? Well, I ran 1,000. You might want to run more than that. Typically, you want to do your prediction within about a day, plus or minus 1 day. So if we take mu there, the U, and X bar is our finish, and then this is kind of our error term right here, right? It's plus or minus Z times the standard deviation, ding ding, over the square root of n, where n is the sample size. Well, what we do is we set that value, that error term, we set that equal to 1 day, and then we know what Z is from statistics, right? It's 1.96 for 95th percentile. I knew what my standard deviation of my task of my program was, 31, and you only know that after you've run it, unfortunately. Set it equal to 1 day, and then we solve for n. So did I do enough? Oh, no, I didn't. I only did 1,000. We should have done 3,500, or we should have done 4,000. In order to guarantee that our granularity was at least have the finesse or the granularity of 1 day. But at 1,000 iterations, if you crank that same value, the error is about plus or minus 1.93 days rather than plus or minus 1 day. So, you know, close enough. We could have run it more, but we didn't. You can also set things to run until it converges. I don't like to do this because then you don't really know when you're going to finish, but if you've run the model a couple of times, you can just set a confidence limit on the tolerances and the confidence level of when the output mean is not wiggling around a whole lot, and you can set it to just stop then, and it'll automatically stop. That's available in the simulation settings. So what did I learn out of doing all this? If you go back to the tornado chart, we learned that systems engineering has more impact to the critical path than we originally thought. When we were doing this, we were given some constraints about we had to have a certain amount of work and it had to occur within a certain time period, but it also had to have a certain amount of dollars that were spent. No more than a certain amount of dollars could be spent up until a given date. So it's kind of balloon squeezing. You know, they said, all right, we're going to put this balloon in a box, but you know, the end date can't move to the right too much. The left date, we know when that is, but if you squeeze the end of the balloon, because we only have enough money to, you know, initially we only have this much money, if I squeeze that balloon on the left end, well, that's just going to push the work out to the right, but I'm also staff limited, so I can't have a big staff hump, right? So that gets to be a problem when you squeeze the balloon there. So we learned that that was kind of difficult and difficult to model as well. So that really says that, you know, the tornado tasks are only one way to go about where you need to throw money. The other is the voice of Maynard Keynes, he who has the gold makes the rules. So we kind of have to take that into consideration as well. It forced us to be more creative in doing things and rewickering tasks and things like that. So other things to consider. What about resource leveling? I did not have resource leveling turned on in project. Might that help us out or in some way? What about leveling delays or overloaded resources? Do we want to make sure that those get turned off? And there are ways to deal with that. I already talked about the money. Reduce the conditional branching if possible. That takes a lot of time. And I already said how to eliminate the correlation if you can. That would be one way to do it. So I guess at this point I want to turn it back over to our presenter, and I guess we have some time for answering questions.
Jim, this was a very interesting presentation. I really appreciate it. It covered some ground that we haven't covered before in a webcast, and I think that it's going to be a great resource too as a recording. I'm going to click on our question panel and see what we have. The first question, of course, is it possible to get a copy of your presentation slides?
Of course.
Okay, great.
I've already sent you a PDF.
Yep. So I'm free to. I'll send that out to our attendees. I'll send out a message and ask who wants it. And again, if you're watching this recording in the future, please feel free to reach out to us too. And let me see what else we have. I realized initially we had a little bit of a audio glitch. I think one of the GoToMeeting has actually reached out to me and said they had some kind of server crash in Palo Alto or wherever they are. So sorry about that, everybody, if you had initially any trouble signing on. Let's see, do we have more questions? Yes, a question about the recording. Certainly, we'll have that archived right on our website, And I can also send out a direct link. I thought that was very interesting what you said about parallel tasks. In other words, you weren't able to lump everything together. I suppose everybody, if they're doing some kind of analysis for different industries, has to follow the rules of what they've set up. And I know the government can be
Yeah,
pretty strict about.
yeah. I usually just say too many rules. It's a lot. Too many rules.
And let's see. Good. Here's some more questions coming in.
Okay.
How would you add the model results for days added back into the schedule as an activity?
As a margin, is that the question? Could you read that question again?
Certainly. How would you add the model results for days added back into the schedule as an activity?
Okay, I'll give my best interpretation, and then perhaps there will be a follow-up.
Yep.
Let's say for example I had a static date in the schedule of a preliminary design review that would occur in January of next year, say 2015. And then the model predicted that you would have a 5% probability of having that design review by April 1st. So notice it's not anywhere in the schedule, right? And that a 90% probability would be May 1st for that. Well, what I would do is I would take the number of days that are between, say, January 15th when you statically had the item done, and then I would also have, I would make a task that I would call PDR margin, and I would run that out to, say, the 90th percentile date, which would be, say, May 1st. And really remember what the histogram shows as the result is the probability that the event will occur in that window. So if my 90th percentile date was, say, May 1st, I would have a margin activity that I would force everything, the successors to PDR, I would link them to the end of that margin task. And then that kind of manually pushes you out to that date. There's another way to do it when you model that. If you want to go back and model it, you could also put a SNET, start no earlier than constraint on, say, for example, that PDR task. And you could put a SNET equal to the margin date, the 95th or 90th percentile date, which would give you, say, May 1st. And then what happens is when you run the model again, you're going to see that your cumulative probability starts at 90% for that task and then goes up from there. So you will have seen the impact of it. So the purpose of doing one of these risk analyses is to show you what that delta might be, and then you can bake that into your task as margin. Then what you can do is, of course, the program owns the margin. You want to schedule and plan for the early date, the January date, but what you're going to advertise to your customers or to the government or whoever, you're going to advertise the May 1st date, right? Then you get a bonus for holding the PDR early, right? And then every day that would slip, say after, say, I'm inventing it January 15th, if your schedule slips to January 17th, then you need to reduce in a future version of the schedule when you status it, you're going to need to reduce your margin by 2 days. And then that way you're still holding your margin date out to the May 1st date and running it from there. So what we did on several programs was we did exactly that. All the predecessors to PDR hooked to as predecessors to the PDR link, and then we had the schedule margin task, and all the successors. For example, the procurement of long lead items is authorized usually after preliminary design review, and then those we hooked to the end of the margin task as successors, so that we had that window in which PDR would occur, and it could slide left and right. So that's how I did that. Hopefully that answers the question. If not, get me offline.
Thanks. Yes. We might not be able to get to all the questions today, so if you If you have more, if you realize we haven't gotten to yours,
Yep.
please reach out to us. Here's an interesting question here. I was interested in how you joined up the sub-projects in order to get the overall program risk. Do you correlate key things between sub-projects, for example, specialist resource, or do you treat each sub-project as entirely independent?
Well, what we have is what might be called handoffs between the project files, so that the project files themselves, external to at-risk, are dynamically linked, so that there are predecessors in file A that drive successors in file B, and then also the results of effort in project B drives through an external link out back to schedule A, so that they are dynamically linked to each other, and that one can push the other. The way we do that is with, we do it with milestones at the top of the file, so that you have givers and receivers between each file, and that works pretty well. It doesn't have to be set up that way, but what I like to do is put givers and receivers at the top of the file, and then I mark them with deadline dates, so that as soon as maybe I own schedule B, and someone says, oh, well, dude, you're delivering 10 days late. The first thing I do is I go look at the top of the schedule and I look at my receivers, because I can't start work until I get a receiver, right? And if that's showing a red date because I've violated a deadline, then I say, well, wait a minute, and I go back and I take a look right there. And if I can assume that I get my receiver on time, then I can say, okay, it is my fault and I am driving you. Let me see what I can do. But if I'm showing up with a delayed task up at the top, I say, sorry, I'm being pushed myself, so we need to go upstream of me. Does that make sense?
That's really interesting. Do you find there is a limit to the number of activities that are used to run the model?
More tasks takes longer.
Yeah.
I personally haven't run into a limit other than the limit of my patience.
Yeah. Good.
Yeah. I've run it to about 24,000 tasks.
Wow, that's great. That's a good testimonial right there. Let's see. I think we have time for one more question in this part. Can you elaborate a little on the difference between process versus product risk?
Sure. A process is how you go about doing something. If you're baking a cake, it says, take these ingredients to these measures, pour them in the plate, pour them in a cup, stir it up, mix it together, throw it in the oven, cook it for this long, right? So that's a process, and the process shows you different things, right? There is each step in that process. And if it's as simple as, break the egg and put it in the cup, that's very low risk, right? But if you think about it, if you wanted to get real granular, well, what happens when I break the egg and a piece of the shell makes it into the cake? And I got to go take time to fish that out. So that's part of your Monte Carlo on that, right? So that would be a process risk. The product risk would be, well, if the process says bake in the oven for 40 minutes, and then I pull that cake out and it's black, I obviously cooked it too long, right? So that would be a product risk. The cake didn't meet the quality specification even after I followed the process to the letter. So that would be a way to do it. Something else, if we relate it to software, maybe I didn't get all the bugs, and even though when it gets out into the field I still have some type of anomalous behavior that I didn't test for, that would also be a product risk. The process might uncover many of the bugs, but not all of them, and then the risk in the product would be what would be remaining.
Well, great. Again, we really appreciate this. I think we have a number of questions still out there. If folks, you can feel free to reach out to me or Jim, and we'll we'll take care of questions as they come up, and I'll
Yeah,
reach out to
if you'd
everybody
like,
soon.
yeah, if you'd like, you could forward those over to me, and of course, question providers, with your permission, I can see if I can answer you via email privately, but I understand I'm not here to collect names or anything like that. So,
Well, great. Okay, hey, maybe we can do this again.
I think that would be my pleasure.
Oh, great. And thank you, everybody. I'll let everybody go now, and thanks, Jim.
Yeah, feedback is important as well. If there's anything that I can improve on here or anything else more detailed that you'd like to see on something, let us know, and we'll see if we can add it to the presentation as well.
Super. Thank you, everybody.